Alright, hope everybody's enjoying their Wednesday night. Just got a quick request to do problem 6b on the homework. So it says, another scientist who worked on the study thinks that the proportion of species that becomes extinct is more directly related to the size of the islands than simply to whether their islands are grouped as big or small. So in other words, this scientist is like, you know what? It's more about whether the island is 10 miles or 20 miles or 30 miles as opposed to saying things are big or small, right? What really matters is the exact size, not just grouping things into big and small, which is what we did in part A. The scientists investigated the relationship between the proportion of extinct birds in the area in square kilometers. A least squares analysis was conducted, and the proportion extinct, and the regression is the following. Here's the data, here's the residuals. Estimate the slope of the least squares regression line, and using a 95% confidence interval, interpret your answer in the context of the situation. Alright, so we're doing 95% confidence interval on the slope. So again, you start with, this is 6b, name is always the first thing. So we're doing a t interval for the slope of the regression line, right? Remember, the confidence interval is going to be talking about b, where b is the slope. You can put beta if you want, doesn't really matter. Slope of the regression line. No need for hypothesis because this is a confidence interval. So next step we go is conditions. So random. We're just going to assume random. And this is not as important, to be honest with you. In fact, I'm going to actually scratch this out. And the reason a random sample doesn't really matter here is because for a regression line, like, you might use all the data, so you might not have a random sample. What really matters is the residuals. And here's the residuals, right? There's no pattern. Some are up here, some are down here. There's no U-shape, so there's no pattern. So I'm going to say the residuals are randomly distributed with no pattern. Okay, that's really the big condition for when you're talking about the regression line, is about the residuals being randomly distributed. We got that. Now we go to math. Math is always confidence interval equals, and again, that's the formula, folks. Formula is right here. Statistic plus or minus critical value times standard deviation. So the confidence interval is the statistic plus or minus the critical value times the SD. So the confidence interval is the statistic. That's what we already got. So here's what we already got for slope. Negative 0.05323. Negative 0.05323 plus or minus critical value. Well, we're doing a 95% CI. And the degrees of freedom are, well, what's the sample size? So I'm going to go back here. Sample size was 13. 13, and how many variables are there? 2, right? There are 2 variables here, so therefore the degrees of freedom are 11. There are 2 variables here. There's x and y, right? There are 2 variables here, y and x. So we don't know what the critical value is yet. We'll get that. Standard deviation is given to us right here, 0.00618. Okay, here's where we are so far. We got to find this critical value, so let me go to the next page. So I'm going to go CI equals negative 0.05323 plus or minus. Now we got to get this critical value. So the critical value, degrees of freedom 11, confidence interval 95%. Let me go to my table. I want to go for T. Let me zoom in here. We want degrees of freedom of 11, so I'm right here on this row. And we want 95%, so I'm going to be right here, 2.201. 2.201 right there. And I'm just going to write that this is with DF equals 11, 95% CI, and it's from the table. And then SD is 0.00618. Remember, this times this is called the margin for error. This can just be done on the calculator. Just literally plug it in, this times this, add it to this, and then subtract it from this. And what you'll get for the confidence interval, I don't have my calculator with me, so I'm not going to show the steps, so I already wrote it down here, is negative 0.0668 to negative 0.0396. A little picture and then the conclusion. So the picture is 96% right here. This is negative 0.0668. This is negative 0.0396. And we are 95% confident. We're talking about slope here, that for each 1 unit increase in natural log of area. And why is it natural log? Because if you look back at the problem, it was natural log of area. So remember, the slope is for every 1 unit increase of this, the y variable, which is the proportion extinct, for 1 unit increase in natural log of area, the proportion extinct and decreases because of the negative, decreases by between 0.0668 and 0.0396. And what are the units? Proportion extinct. The proportion extinct decreases by between this and this. So in other words, as the area goes up, so as the island gets bigger, the proportion decreases. The proportion of extinct decreases. So here you go, folks. This is 6B. Hope this was helpful, and I will see you all tomorrow.